नमस्कार बच्चों, माय नेम इज धन्या। मैं एक साइंस टीचर हूँ, केमिस्ट्री टीचर हूँ। आज हम लोग ग्रेड 11 केमिस्ट्री का फर्स्ट लेसन देखेंगे, विच इज सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री। ओके, सो ग्रेड 11 का फर्स्ट लेसन, सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री। इसमें हम लोग आज वी विल बी लर्निंग द 5 laws of chemical combination. Okay, so today 5 laws of chemical combination we will learn. Okay, so as we move on, every video you will come across some questions that has maybe some past paper JEE question, NEET question, etc. in every topic. So today's topic is laws of chemical combination. Okay, so okay, now whenever any compound is formed, in this case, I have just represented, if you see, okay, students, the laws of chemical combination. Now, whenever any elements, they combine to give you a compound, or whenever the reactions are taking place, okay, so these laws tell us how much of the elements are combining, in what ratio they are combining, or in how many moles they combine to form the product, or in what percentages they are combining. So all this you get from this laws. Okay, so law of chemical combination is tells you, the different laws tell you the different amounts or the different masses or different moles of the reactants that combine to give you the product. Okay, so jab bhi reaction, let's move on. The first law of conservation of mass. This is the first law, and it was given by Anthony Lavoisier. Okay, so in this law, whenever elements combine to form the compound or the product, the mass of the reactants is equal to the mass of the product. Okay, so जितना reactants react करता है, उतना products हमें मिल जाता है. For example, यहाँ पे A and B reactants है. AB is the product. Okay, so if 10 grams of A is reacting with 10 grams of B, we should get 20 grams of the product according to the law of conservation of mass. Okay, इसका एक और statement है, mass can neither be created nor be destroyed. चलो ये देख लेते हैं हम लोग. ये reaction दिया है मैंने, carbon plus oxygen giving you carbon dioxide. Okay, so carbon plus oxygen giving you carbon dioxide. Okay, so I'm just giving you the masses. Carbon is 12, oxygen is 16. Don't worry about the masses, because by experience you can by heart it, and also it will be given to you. Okay, the masses. Okay, anyway, first 20 elements to आपने grade 10 तक तो पढ़ ही लिया होगा, तो definitely some of it you must be knowing. Anyway, so carbon and oxygen are the reactants, and carbon dioxide is the product. Okay, so what does this law says is, the sum of the masses of the reactant should be equal to the mass of the product. Okay, in this case, there's only one product, but there can be many products as well, right? So carbon is 12. Let's see the masses. So I've given you the masses over here. So carbon is 12. Oxygen 16 hai, but there are 2 oxygen atoms. So total kitna hua? It is equal to 44 grams, right? Okay. यहाँ पे carbon है 12, products का देख रहे हैं हम लोग. 12 plus 16 times 2, because there are 2 oxygen atoms, right? So 12 plus 32 equal to 44 grams. So this is the law of conservation of mass, that says that sum of mass of product, sum of reactants, sum of mass of the reactants is equal to the mass of the product. This is a very old law. So this we have proved that the sum of mass of the reactants is equal to sum of mass of the products. Okay, now there's another statement, mass can neither be created nor be destroyed. Okay, so कोई सा भी statement आप by heart कर सकते हो. बहुत पुराना सा लॉ है, as you can see 1789, it's very old law. Okay, ये एक another reaction is there. You can see 10 grams of calcium carbonate is heated to give you 4.4 grams of carbon dioxide and 5.6 grams of calcium oxide. Okay, so इसमें देख लेते हैं. So ये एक, so इसमें reaction है calcium carbonate is reacting with carbon dioxide plus calcium oxide. इसमें according to the question 10 gram of calcium carbonate they have given, and when they react it is giving you 4.4 grams of carbon dioxide and 5.6 grams of calcium oxide. So इन दोनों का total, ये तो एक ही reactant है, it's given 10 grams. अगर आपने ये product का mass लिया 4.4 and 5.6, it comes to how much grams? 10 grams, right? So this is the law of conservation of mass. ये basic सा law है. Okay. Moving on to the second law, which is called as law of definite proportion. Okay. So this law was given by Joseph Proust. Okay. Now, in this law states that irrespective of the source, okay, the compound is always contain, the compounds always contains the elements combined in the same ratio by mass. For example, the simplest example which I can give is water. Now, if it's water, you know the formula is H2O, right? So, in water, the simplest example of law of definite proportion which I can give is water, okay? So, this law states that irrespective of the source, a compound is made up of elements combined in the same proportion by mass, irrespective of the source. Okay, so if I talk about water, the formula is H2O, right? So whether it is tap water, whether it is sea water, whether it is rainwater, forget about the impurities. I'm just talking about the chemical compound water that is made up of H2O. Okay. Now, H2O, hydrogen is 1, oxygen is 16. Okay. So don't worry about the masses now. You will be able to memorize it as you move on. Okay. So tap water is also H2O. Seawater is also H2O. Rainwater is also H2O. Okay. So irrespective of the source, whether it is tap water, seawater, or rainwater, okay, the compound contains the elements combined in the same ratio by mass. Okay, let's check out that. Hydrogen is 2, the mass is 1, but there are 2 atoms. So let's check out the ratio. This is 16. Here also it is 2 is to 16. Here also it's 2 is to 16. And the simplest ratio is 1 is to 8, 1 is to 8, and this is also 1 is to 8. So this is the law of definite proportion, that irrespective of the source, the elements always in a compound, the elements are combined in the same proportion by mass. So whether it is tap water, whether it is seawater or rainwater, hydrogen and oxygen are combined in the ratio 1 is to 8, irrespective of the source. Even spring water, river water, well water, whatever it is, hydrogen and oxygen, they are combined in the ratio 1 is to 8. Okay, so irrespective of the source, the elements are combined in the same ratio by mass in a compound, in a particular compound. Okay. Similarly, I have taken an example from your NCERT book. Okay. And we will do a question also regarding this. Okay. So here there is a there's an example from your NCERT book here, cupric carbonate. Okay. So whether it is natural sample or synthetic sample, the ratio is always the same. Okay. Now let's do an example regarding the law of definite proportion. So here, this is the question. Okay. So in this question, magnesium is reacting with oxygen. Okay, and you have in the first set, you have some masses of magnesium reacting to give you magnesium oxide. In the second experiment, you have yet another mass of magnesium that's reacting with oxygen to give you magnesium oxide. So you have to prove that the data is following the law of definite proportion. Okay, now I'll just write down the information in the tabular form. I'll just share the screen. Okay, so whatever information is there, I'll make it in the form of a table. So you have magnesium is reacting with oxygen. I'll write the symbol, okay, and you have magnesium oxide, right? There are two experiments, 1 and 2. In the first one, I'll just write down the numbers. 0.243 grams of magnesium is reacting with oxygen. How much of oxygen they didn't mention? We have to find out that. 0.403 of magnesium oxide you get. That's given in the question. In the second set of experiment, 0.182 is reacting to give with oxygen, don't know how much, to give you 0.302 grams of magnesium oxide. Okay, now, so that means this is the reaction. Magnesium is reacting with oxygen to give you magnesium oxide. Okay, so I've just balanced it. Now, magnesium oxide is formed in two experiments, okay, and different masses of magnesium is reacting with oxygen. Okay, now we have to prove the magnesium oxide formed, right, or we have to prove that they are following the law of definite proportion, right? Now here, oxygen, how do we get the amount of oxygen? Magnesium oxide is in the first experiment. Let's talk about the first experiment, 0.403. And magnesium is 0.243. How can you get oxygen here? Can we subtract it? Reactants minus the product. Product minus the reactant. Can we get, you can get it, right? So 0.403 minus 0.243. If you subtract it, you can get the mass of oxygen, because we already learned the first law of conservation of mass. The sum of masses of the reactant is equal to sum of mass of the product. So it comes to 0.160. This is 160. Okay, so just this is 0.160. Similarly, can we do the second one? This one is 0.182. This one is 0.302. Similarly, we can get oxygen, 0.302 minus 0.182, which gives 0.120. Now, in this, we are talking about magnesium and oxygen. In what ratio they are combining? Just remember what we did for water. For different sources. Did we find the ratio between hydrogen and oxygen for different sources? Tap water, spring water, well water, rainwater, etc. Similarly, we have to find the ratio between the reactants in both the cases, and we have to prove that they are the same for both the experiment. In the first experiment, let's check the first experiment. It is 0.243 over oxygen. How much is oxygen in the first case? 0.160. It comes to be roughly 1.5:1. We cannot put the ratio in decimals, so we are making it in as a whole number ratio by multiplying both of them with 2. Second experiment. The mass of magnesium is 182 and oxygen is 0.120. This also comes to be roughly 1.5:1. So similarly, we do it as whole numbers multiply with 2. So students, here you can see in law of definite proportion, we take the ratio between the masses of the reactants. Okay, so here magnesium and oxygen are the reactants. In experiment 1, we took the ratio between magnesium and oxygen. In experiment 2 also, we took the ratio and we saw that both are the same. So irrespective of the source, the elements are combined in the same ratio by mass. Okay, so whether, just remember the simplest example of rainwater and seawater, etc. Okay, forget about the impurities. They are not chemically combined. So we are talking about the elements that are chemically combined. Okay, so this is the one that we did already. So ratio of magnesium and oxygen are the same. Okay. Now, students, this is the third law, law of multiple proportion. Okay. Law of multiple proportion. Now, in this law, when two elements combine to give more than one product, okay, when two elements combine to give you more than one product, the different masses of one element that combine with the fixed mass of another element, they are in a simple whole number ratio. Okay, so let's check. Okay, so just sharing the screen. Okay, so we are doing the law of multiple proportion. Now, in this, what is the first part of the statement? When two elements combine to give you more than one product. Okay, let's check out the simplest one. Carbon is reacting with oxygen. Okay, it can give you CO, carbon monoxide, when it is incomplete combustion. Incomplete combustion means when there's less supply of oxygen. Okay, and it can also give you carbon dioxide when there's complete combustion, when there's a lot of oxygen. Okay, now when two elements, here we are talking about carbon and oxygen, they combine to give you more than one type of compounds, right? You're getting carbon monoxide and you're also getting carbon dioxide. Okay, carbon is 12, oxygen is 16. Okay, the different masses of one element that combine with the fixed mass of one element, there's a whole number ratio. Let's check out. Okay. In this case, we have to talk about the mass here. So this is 16. Carbon is 12. Okay. Here the carbon is 12. Oxygen is 16 times 2. That is equal to 32. So which one is fixed mass here? Carbon is fixed mass, right? In this case. And which one is the different mass? It is oxygen. Different mass. So when two elements combine to form more than one product, then the different masses of one element that combine with the fixed mass of another element bears a small whole number ratio. So that means we have to find the ratio between the two oxygens in the two product because carbon mass is the same in both the cases. So in this case, 16 is to 32. They are saying this ratio should be a simple whole number ratio. So how much is this ratio? Is it 1 is to 2? Isn't it a small whole number ratio? So this is the law of multiple proportion. When two elements combine to give you more than one product, then the different masses of one element that combine with the fixed mass of another element bears a simple whole number ratio. Okay, so let's check out with an example. Okay. Can you see a question there? So 3.2 grams of sulfur combines with 3.2 grams of oxygen to form a compound in one set of conditions. Okay, so यहाँ पे two elements are combining to give more than one products, okay? But the elements are the same. I mean, the reactants are the same, but the products are different. And the mass of one element is fixed in the product side and the other one is different in the product side. And in another set of condition, 8.8 grams of sulfur combines with 1.2 grams of oxygen to form another compound, okay, just like carbon monoxide and carbon dioxide, okay. Prove that this above law illustrates the law of multiple proportion. Let's check out. It's a little bit big statement, but with examples, you will understand, okay. So यहाँ पे sulfur is, what are the products and all? They aren't saying, they are just saying about the elements, okay. So the first product, first set, I'm just writing down the information that's given in the question, okay. Sulfur is 3.2, right? 3.2 grams. Oxygen is also 3.2 in the first set of conditions, right? In the second set of conditions, sulfur is 0.8 and oxygen is 1.2. Okay. So these are the two conditions. Sulfur and oxygen are reacting. Okay. So chalo, let's do the first case. कौन सा fixed है, कौन सा variable mass है, नहीं मालूम. So we have to fix one of them as fixed one. Okay. So 3.2 grams of sulfur, I'm talking about the first case, okay, is reacting with 3.2 grams of oxygen. So let's fix sulfur as fixed one. 1 gram of sulfur will react with how much? 3.2 over 3.2 grams. That means 1 gram of oxygen. Okay, because they haven't specified, we can make it like that. Second set. 0.8 grams of sulfur is reacting with 1.2 grams of oxygen. इसको भी fix कर देते हैं 1 gram of sulfur so that we can fix one of them as fixed mass. So sulfur को कर देते हैं 1.2 by 0.8, which is equal to 1.5. So sulfur is fixed as 1, which is the variable mass here. The oxygen is the different mass here. So the different mass of oxygen that reacts with the fixed mass of, so oxygen is different mass here. So the different mass of oxygen that react with the same mass of sulfur bears a simple whole number ratio, okay? Or fixed mass of sulfur bears a simple whole number ratio. So the different masses of oxygen that reacts with the fixed mass of sulfur bears a simple whole number ratio. So what are the two masses of oxygen? 1 is to 1.5. So we cannot keep it as a decimal. So we have to fix it as 2 is to 3. So here in this case, they gave you the masses of the reactants, but they didn't tell you which one is fixed. So we can just fix one of them. Okay. And then prove that the two oxygens, the different masses, are in a simple whole number ratio. Let's check out one more example. Okay, hope this is clear for you, right? One more example of law of multiple proportion. ये देखो, यहाँ पर भी दो cases दिए हुए हैं. Question number 2, I'm referring to question number 2. In question number 2, copper combines with oxygen to form 2 oxons. Okay. So they have given you the masses. You have to prove them as law of multiple proportion. Okay. So let's check out. So here they have given you the masses: copper, oxygen, copper oxide. Okay, I'm just writing down for the first one and the second one. Okay, so first one is oxygen is 0.636. This one is 0.716. And Copper का दिया नहीं हुआ है. So how can we find out for copper? Same that we have as we have done before. Products minus one of the reactants will give you the mass of the next reactant. Law of conservation of mass. Okay. So we get 0.716 minus 0.636, which is equal to how much? 0.08. Okay, this is the first case. This is the first case, first experiment. दूसरे experiment में same, the reactants are the same. Okay, product. Maybe instead of instead of you're getting this copper oxide, you're getting another copper oxide, okay? Because copper has different forms. So in the second one, 0.398 is copper oxide, yes, 0.398. And oxygen is 318. So how much is copper? Same way, 0.398 minus 0.318. Also, you're getting 0.08, right? So which one is fixed mass? Here it is clearly copper is the fixed mass, right? See, you can see in both the cases you have got 0.08. So which is the different mass over here? Oxygen. So different mass of oxygen that reacts with the fixed mass of copper bears a simple whole number ratio. So this is simple. So let's check out the ratio between the two oxygens. 0.636 by 0.318 is giving you roughly 2:1. So isn't it a whole number ratio? So the fixed mass of one element, the different masses of one element that reacts with the fixed mass of the next element bears a simple whole number ratio. Okay. So let's check out one question that came it's one of the NEET past papers. Okay. If you see question number 3, it's NEET past paper. So students, as we do different topics, we will be doing some NEET questions. Okay. And also, after completing one lesson, I will be discussing some questions on NEET questions, okay, past paper NEET questions. In between the lesson, few NEET questions I will be discussing, okay. So, यहाँ पे the amount of metal in the two oxides, okay, amount of metal in the two oxides is 72.4. This is the first experiment. Second experiment, it is 70. So they have told metal oxide. Okay, so that means it's between a metal and an oxygen. The formula of first metal is also given. I'll just write it at the side, M3O4. Okay, so you have to find the formula for the second oxide, right? So here, reactants are the same. So they are forming metal oxide, right? So this also is a part of multiple proportion. Let's check out the formula. I'll just share the screen. देखो बच्चों, मैंने informations लिख दी है. There are two informations about metal. In the first case, the mass of metal is given as 72.4%. अगर percentage of metal दिया हुआ है, तो oxygen, how do you get the percentage of oxygen? So whenever percentage is given, percentage of one element is given, the second element you get by subtracting from 100, 72.4. Okay, so it is 27.6 oxygen. Similarly, in the second case, metal, the percentage is 70. So how do you get oxygen? 100 minus, that is also in percentage. So you get as 30. Now, formula of the first metal. Formula of first metal is M3O4. right? M3O4. This is the formula of metal oxide they have given. This is the formula for the first metal. They are referring to the first one. Okay. You have to find the formula for the next metal oxide. Let's check out how do we do that. Now, let's check the information of the first one. Okay. So मैं ये ऐसे एक table बना देती हूँ. Okay. So according to this, metal for the first one, it is 72.4% of the metal. Okay. This 72.4 refers to how many metal atom? 3 parts of the metal atom. Remember, we are talking about the same metal M in the first experiment and the second experiment. The metal is not changing, oxygen is not changing. Okay, only the formula is changing, the amounts are changing. Okay, now, so 72.4% of the metal refers to how many parts of the metal? 3 parts of the metal. Because we are talking about the same metal, so 72.4 refers to 3 atoms. Okay, so the same metal 70 will refer to how many atoms? That's what we need to find out. So if we cross multiply like this, now X is 70 times 3 by 72.4, which is equal to 2.9. So it's a decimal. Just hold on like this. We will find out about oxygen and we will make it as a ratio. So let's check out if we get a whole number or not. Okay. So this was about the metal, right? So I just assume that because the metal percentage for the first metal oxide is 72.4, and the formula, according to the formula, 72.4 refers to how many metal atom? 3 metal atom. 3 metal atom, right? Because it's the same metal. If 72.4 refers to 3 parts of the metal, 70 will refer to how many metal? That I took it as X and I cross multiplied it and I got X as 22.9, 2.9. Okay, so I'll just keep this aside because I have to find out for oxygen also, 2.9. So the metal is 2.9. So this was my formula, M3O4. So we found out for the metal, but for oxygen, similarly, 27. So this is the first metal and this is the metal. I'm keeping it at the side. Now, oxygen. I'm talking about oxygen now. For oxygen, for the first one, 27.6% of oxygen refers to how many atoms of how many oxygen atoms? It's given in the question, right? Refers to 4 oxygen atom. So, because it's the same atom, oxygen, it's not a different element. It's the same element, oxygen. So 30% will refer to how much? X. Same like the previous one we did for metal. Okay. So when I cross multiply it, X, we get it as 4.35. This was for oxygen. Okay, so 4.35. Oxygen is 4.35. So metal is to oxygen. 2.90 is to 4.35. Okay, it roughly gives me 2 is to 3. So the formula is M2O3. So because we are talking about the same metal, we are talking about the same oxygen. So in the first one, we just wrote 72.4 parts of the metal refers to 3 metal atom because the formula is given for the first oxide. So 70 parts of the same metal will give how many atoms? And then we cross multiplied it and we got the amount of metal. Similarly, we got for oxygen and we made it in the form of the ratio. and we tried to simplify it, and it gave you M2O3. Okay. So this was one of the NEET questions. In one of the questions, the same question, they gave the percentage of oxygen, and you had to find the percentage of metal and the formula. Formula was given for the first metal oxide. The second metal oxide you had to find out. Okay. So this was one of the NEET questions. So, okay. This was the law of multiple proportion. I hope बच्चों आपको समझ में आ गया होगा अभी तक law of multiple proportion. Okay. स्टेटमेंट्स ऑफ द लॉ स्कूल एग्जाम्स के लिए काफी इंपॉर्टेंट होते हैं, कभी कभी पूछ लेते हैं स्कूल्स में. कॉम्पिटिटिव एग्जाम्स में ऐसे वैल्यू देके आपको फॉर्मूलाज पूछते हैं, और these type of questions are very important. Okay, ratios पूछ लेते हैं. Okay, now before we move on to the fourth law, the law of reciprocal proportion. Okay, now law of reciprocal proportion. Reciprocal means in multiple proportion, we were talking about only two elements. Two elements, they are forming more than one product. And the variable mass or the different masses of one element is combining with the fixed mass of another element. They bear a whole number ratio. And in reciprocal proportion, but when I say explain an example, you will understand. Okay, when two elements combine separately with the fixed mass of the third element, then the ratio of the masses in which they do so bears a small whole number ratio to the ratio of the masses in which they themselves combine. Okay, one thing that you have to bear in mind is law of reciprocal proportion. It involves three elements. Okay. Let's check out. Okay, so share करती हूँ screen. Okay. The first part of the statement. When two elements combine separately with the fixed mass of the third element. Okay. So carbon and sulfur. When two elements, carbon and sulfur are my two elements. Okay. The mass लिख लेती हूँ यहाँ पे 32. Oxygen is 16. Okay, so carbon and sulfur are my different elements, are combining with fixed mass of third element. My third element is oxygen. Okay, carbon and oxygen is giving you carbon dioxide. Consider that it's a complete combustion. Sulfur and oxygen is sulfur dioxide. Okay, let's check out the masses first, then only I can explain the second part of the statement. Carbon is 12, is 2. Oxygen is 16, but because there are two atoms, it is 32, right? So it is 3:8. Okay. Now the next one, sulfur is 32, is 2. 16 times 2, that it's equal to, that is 1:1. Okay. Now, when two elements, carbon and sulfur are my two elements, that is combining with the fixed mass of oxygen. Just check. Is my oxygen mass fixed? Just see, I'm referring with another color. So oxygen mass is fixed. It's 32, right? So when two elements are combining with the fixed mass of the third element, then the ratio in which they combine, so the ratio in which they combine is 12 and 32. Okay, so this is my first ratio. बच्चों यहाँ पे दो ratio है, so I'm taking this as ratio number 1. So I'm repeating the first part of my statement. When two different elements, sulfur and carbon and sulfur are my two different elements. They're combining with the fixed mass of oxygen. I already told you oxygen is fixed. See, 32, 32. Okay. The ratio in which these two elements combine, that means I'm talking about carbon and sulfur. The ratio in which they combine, okay, let's find out that ratio. So 12:32, which is equal to Yeah, 3:8. So this is my ratio number 1. Now this particular ratio bears a simple whole number ratio when the elements themselves directly combine. So that is when they directly combine, it is CS2. That is ratio number 2 when CS2, when carbon and sulfur directly combine. What ratio they give, that's ratio number 2. That is 12 and 32 times 2. That is 64. Right. So that means it is 3:16. Now, this is ratio number 2. So ratio number 1 and ratio number 2, they bear a simple whole number ratio, that is 3:8 over 3/16, which is equal to 2:1. Isn't it a simple whole number ratio? I repeat once again. When two different elements, that is my carbon and sulfur are my two different elements, they react with fixed mass of oxygen. Fixed mass, we already proved, 32 and 32. Mass of oxygen is fixed in this case. I have shown with a red color. When they react with a fixed mass of oxygen, then the ratio in which they combine with oxygen, that is ratio number 1. The ratio in which they combine with oxygen, that is ratio number 1, 12:32, bears a simple whole number ratio when they themselves combine. That means CS2, when carbon and sulfur directly combine, that is ratio number 2. So ratio number 1 and ratio number 2 is a simple whole number ratio. Okay, so this we will illustrate with one more example. Okay, so you just have to remember in this case, law of reciprocal proportion, there are 3 elements that are involved. Okay, so I'll just share the screen once. I'll just share the screen once again. Sorry. I'll take another example with another set of elements. Okay. Sulfur is reacting with sulfur and oxygen are reacting with hydrogen. So two different elements, sulfur and oxygen, are reacting with fixed mass of hydrogen. Okay. So sulfur and hydrogen reacts to give H2S. Hydrogen and oxygen reacts to give water. Hydrogen is 1, oxygen is 16, sulfur is 32. So first, what do we have to do? We need to find the ratio, right? First, before we do the ratio, let's check out the when two different elements combine with a fixed mass. So let's do that ratio. So hydrogen is 1, but there are 2 atoms. So 2:32. Here also hydrogen is 1, but there are 2 atoms. So hydrogen is fixed over here. So 2 elements combining with a fixed mass of hydrogen. They bear a simple whole number ratio. So ratio number 1 is between sulfur and oxygen. 32:32. That is 1:1. It is between the elements that have different masses in this case. Okay. Now, bears a simple whole number ratio when the elements directly combine. That is ratio number 2. That is sulfur dioxide. That is ratio number 2. Sulfur and oxygen. This is 32. 32 times 2. That is 32 times 16 times 2 is 32. 1:1. Right? So do they bear a simple whole number ratio? Yes. 1:1 by 1:1. That's a whole number ratio. Okay. So this was about the law of reciprocal proportion. Okay, the statement is big, but if you see the example, you will understand. Okay, hope that you understood this one. So here, three elements are involved. Okay. Now now we come to the fourth law. Okay. Gay-Lussac's law. This is also a very old law, 1808, and it was given by Gay-Lussac. Okay, this mainly deals with gaseous elements. Okay, so as the statement suggests, when gases react, they do so in volume, and they bear again ratio. So as I told in the beginning of the lesson itself, these laws help us to determine how much mass of the reactants reacted or in what ratio they react. Okay, how much of percentages of the reactants are reacting. So we were dealing with all these, right? So Gay-Lussac's law says that when reactants react, they do so in volume that bears a whole number ratio with one another and with the gaseous product. But one condition is there, it deals with gaseous reactants. Okay, so let's check out. Let's do this example itself. Okay, methane is reacting with oxygen. Let's just share the screen. Okay. So this is the combustion of methane gas, carbon dioxide plus water plus energy. Plus energy I'm writing here. And over here, methane is in the gas form, oxygen. Okay. So if this is steam, we write it as gas. Otherwise, we don't consider. Okay. So let's just balance it. These balancing numbers that I have written is called as stoichiometric coefficient. Okay. So here, in this case, in case of methane, if no number is written, that it's equal to 1. Okay, so these are called as stoichiometric coefficients. Okay, now, if no number is there, that's equal to 1. So in this case, we have one volume. So as I told, Gay-Lussac's law means what? When reactants react, they do so in volumes that bears a whole number ratio with one another and with the product. Okay, so one volume of methane is reacting with two volume of oxygen to give one volume of carbon dioxide and two volume of steam. If it is liquid water, we will not write this one. Suppose in case they write it as in the question, if we talk about liquid, L stands for liquid, we will ignore this. We will not use this. Okay. If it is steam, gas, water vapor, then we talk about, we will use this in Gay-Lussac's hypothesis. Okay. So according to the Gay-Lussac's law, when reactants react, they do so in volume that bears a simple whole number ratio with one another and with the product. Okay, but everything should be in the gaseous form. We talk about only gaseous reactants and product in this case. Okay, let's check out an example. Okay, so in this particular case, you can see that it's a liquid over here. Yeah, it's a liquid. So we will not use this for Gay-Lussac's in this equation. Okay. I mean, we will not use it to solve using Gay-Lussac's law. Okay. So because it's in the liquid form. Okay. Let's check out another example where we can solve it. Okay. Now over here. Here you have 400 milliliter of hydrogen is reacting with 400 milliliter of oxygen. They are mixed and ignited. What volume of water vapor is formed? That means it's a gaseous form. So we can include using, we can find out the amount using Gay-Lussac's law. Okay. So Let's write down the equation. There are three questions. Which element is in excess? Third one, what is the volume of residual gas? I'll tell you what is residual gas. Let's first write down the equation. Okay. So in this case, hydrogen is reacting with oxygen to give you water. First, you have to balance it because we use the stoichiometric coefficients. Okay. Okay. Now, from this, we use the stoichiometric coefficient. Here it is two volumes because it is gas. This is gas, and they told that this is steam. So it's also in the gas form, right? So from the equation, we say two volume. Stoichiometric coefficient is nothing but the balancing number that you're using. If no number is there next to the number, we use it as 1, okay? We don't use 0 because 0 means that element is not there, okay? So 2 volume of hydrogen is reacting with 1 volume of oxygen to give you 2 volume of steam. I'll not take water, I'll use it as steam because that's the gaseous form, okay? Now, what you have been provided is 400 ml of, this is, so I'll just write it over here, provided, what you are provided with, you're provided with 400 ml of hydrogen and 400 ml of oxygen. First part of the question is how much of water, or sorry, how much of steam you're getting. Okay. Now you must consider 2 volume of hydrogen is reacting with only 1 volume. 2 volumes of hydrogen is reacting with only 1 volume of oxygen. Okay. And you are given 400 and 400. Right. So that means oxygen needed is just the half because 2 volumes is reacting with 1 volume. So if here 400 ml of hydrogen is reacting, how much of oxygen is needed? Does it need the whole of 400? No, because it needs only 1 volume. So that means how much it is needed? It needs only 200, half the amount, right? And here, how much of steam you're getting? 2 volume. 2 volume refers to how much? 400 ml. So we are going with the balancing numbers, the stoichiometric coefficient. So here, according to the stoichiometric coefficient, 2 volumes of hydrogen is reacting with, it needs only half the amount, 1 volume of oxygen. So you are provided with 400 ml of hydrogen and 400 ml of oxygen. But you don't need the whole amount. You need only half the amount of oxygen because it's just 1 volume, see? So I take it as 200. Okay. Now, the first question was how much steam is provided? How much of steam you get? So the first answer is this one, 400 ml, because you are getting 2 volumes of steam. 2 volume refers to how much? 400 ml. Right? Now, the second part of the question is, let's check the question. Which element is in excess? We already know we are provided with 400 ml of oxygen, but how much being used? Only 200. So second part of the answer question is oxygen. We used only 200 ml. Remaining is 200 ml. Okay, out of 400, we used only 1 volume that refers to 200 ml, and the remaining 200 ml is in excess. Okay, the third one is residual. Residual means what all you get. Okay, or what all is remaining after the experiment is over. So we have 400 ml of steam. Also, you have 200 ml of oxygen, unreacted oxygen, I have to write. Unreacted Spelling is wrong. Unreacted oxygen. So if they ask you the total amount, you have to say 600 ml. If they ask you separately, 400 and 200. And what all are 400? Is the steam, 200 is the unreacted oxygen. If they ask you the total, just add it up. That's it. So this is how you solve the Gay-Lussac's solve questions using Gay-Lussac's law. Okay, and it applies only to what kind of substances? Gaseous reactants and product. Okay, and these volumes that you take, see, they are in the whole number ratio. 2 volumes reacting with 1 volume, giving you 2 volumes, right? So hope this is clear for you. Okay, so this also they can ask as a question, right? Now, the last one, the last law is the Avogadro's law. Now, Avogadro proposed that equal volumes of all gases, okay, at the same temperature and pressure should contain equal number of molecules. So, Avogadro's law or hypothesis, this, according to this Avogadro's law, keeping all the physical conditions like temperature and pressure the same, okay, equal volumes of all gases contain equal number of molecules. Let's check out how, okay? Or let's check out what this law says. So, if I'm taking a container and I'm filling it with hydrogen gas, okay? And the volume is 100 ml. So, and if I assume 100 ml of hydrogen has Y molecules, keeping the physical conditions the same, temperature, pressure, and all other physical conditions the same, that means if I remove hydrogen and fill it with carbon dioxide, the volume is remaining the same. Okay, all the conditions also same. That means 100 ml of carbon dioxide will also be Y molecules, because that's what the rule says, hypothesis says. Equal volumes of all gases, keeping all physical conditions same, pressure, temperature, etc. the same, equal volumes of all gases will have same number of molecules. So similarly, 100 ml of ammonia, how many molecules will it have? It will have Y molecules. But if I half the volume, 100 ml of carbon dioxide, suppose, how many molecules will it have? Will it have Y molecules? No, that also will be half, Y by 2. If I double the volume, suppose 200 ml of, not double, 2 times. If I make the volume 2 times, it will have 2 times of molecules. So that means volume, keeping all physical conditions the same, temperature, pressure, etc. the same, equal volumes of all gases contains equal number of molecules, and also volume is directly proportional to number of molecules. If you increase the volume, number of molecules also increases. If you reduce, they also reduce. Okay, so volume is directly proportional to number of molecules. So this was about the Avogadro hypothesis. Okay, so after learning about the number of moles and the stoichiometric equations, etc. We will be doing more of NEET questions and JEE questions. So in my next video, we will be learning about percentage composition, the mole concept, okay, the stoichiometric equation, empirical and molecular formula, all these, and we will be solving some NEET questions as well. Okay, and after completing the whole lesson, we will be having one video where I'll be solving many NEET questions from a lot of past papers. Okay, so students, that's all for today. So today we learned about the 5 basic law along with one extra law of reciprocal proportion, and I discussed some questions as well. Okay, so thank you, students. Have a great day.